The cognition of artificial neural networks fundamentally relies on a categorical approach, aiming to analyze and classify information into specific concepts or patterns. These networks do not simply reproduce a predefined objective reality. Instead, they construct representations that reflect interactions, generating new meanings between themselves and the data they access. In this episode, we'll explore fascinating issues. What are these synthetic thought categories made of? And how do these categories become gradually refined and relevant as they progress through the deeper layers of the neural network, enabling the AI system to excel at its tasks? The activation intensity of an artificial neuron when presented with a word indicates the strength of its response to that word. This activation strength reflects how well the neuron recognizes or detects the word, essentially, how much the word belongs to the synthetic category associated with that neuron. Consequently, a set of words that strongly activate the same neuron significantly belong to the specific category represented by that neuron. We examine the statistical characteristics of the 100 most frequently recognized words, or tokens, this means subword units, by the 12,800 neurons in the first two perceptron-type layers of OpenAI's GPT-2 XL language model. This represents 1,280,000 word appearances. In our previous study, we identified a surprising phenomenon related to synthetic categorical cognition: periactivational semantic divergence of core tokens. This phenomenon occurs when words strongly and equally activate the same artificial neuron. This indicates they are analyzed as belonging to the same synthetic category associated with that neuron at the same rate. However, these words are not necessarily semantically close, at least from a human semantic perspective, contrary to what one might intuitively expect. Here are a few examples: house and phone, cat and light, or pen and heavy. In the same previous study, we explained that this semantic divergence occurs because these words belong to different subcategorical dimensions, each specifically targeted by the neuron in question. In other words, each word preferentially activates a distinct subcategorical dimension, making them semantically divergent from a human observer's perspective. However, in a new study, we observed that this phenomenon evolves. Indeed, when we present to a neuron words that do not just strongly activate it, but activate it very strongly, another property emerges: semantic convergence of these words towards stable elements of meaning like managerial, strategy, tactic, manager, and coached. One of the mathematical functions defining each artificial neuron's operation explains this phenomenon: the aggregation function. In a simplified way, here's how it works. Through a mechanism of selective weighting, the aggregation function focuses the neuron's categorical attention, attentional focusing, on specific subcategorical dimensions of interest to the synthetic category represented by that neuron, such as music, electricity, military, cooking, IT equipment, cryptology, or construction, and this focus, through a process of dilatation of the space of subdimensions, allows the neuron to better differentiate between words and then give them particular importance when they are the object of the following process. And through a process of addition, or more precisely, categorical phasing, each neuron particularly selects very specific words positioned at the intersection of its preferred subcategorical dimensions. These words very strongly activate the neurons because they accumulate the activation potentials of each subdimension simultaneously involved. For example, the word battery lies at the intersection of the subcategorical dimensions music, electricity, military, and cooking. Similarly, the word key intersects subcategories like IT equipment, cryptology, music, construction, and tooling. Such polydimensional words trigger maximum activation in neurons specialized in detecting these particular subdimensions through a mathematical optimization process. The process of selecting words positioned at the intersection of various subcategorical dimensions reduces the semantic degrees of freedom of the words that can be chosen. Only certain words belonging to a well-defined lexical field can simultaneously lie at the intersection of these subcategorical dimensions. For instance, at the intersection of subcategories UK, manager, and foot, only specific words can be selected, such as Wenger, Ferguson, or Southgate, which are names of English football club managers. This process of categorical intersection acts like a semantic potential well, delineating a restricted semantic zone within which only a few rare words can reside, thus constituting a precise and unambiguous categorical space, a phenomenon captured by the concept of semantic convergence. In part, synthetic thought categories carried by artificial neurons are alien concepts, or at the very least, heterogeneous polysemous constructs. That is to say, statistical constructions born of neural learning do not necessarily correspond to existing thought categories within human culture, or to concepts for which humans have invented labels. This is because, as we saw previously, synthetic categories group subcategorical dimensions in ways unfamiliar to humans. For example, humans typically do not group dogs, optical instruments, and punctuation symbols into a single category. Synthetic categories, however, might do so if this grouping statistically improves the system's performance on its training tasks. Nonetheless, the semantic convergence observed in the words that very strongly activate neurons to which they are subject could therefore very well be a convergence towards categorical zones, which would also correspond to such alien concepts. However, this is not particularly the case, at least only at the level of the early neuronal layers that we studied in our present investigation. This is because the synthetic categorization activity of formal neurons is goal-oriented. Ultimately, these neurons aim to perform human tasks, which require a minimum alignment with human categories of thought. This alignment ensures adaptive coupling between alien concepts and the human sphere of meaning, as described by neuroscientist Francisco Varela. Semantic convergence, observed in strongly activating words, thus represents a subcategorical transition zone at the interface of two worlds of meaning: the synthetic cognitive entities of neural networks and the sphere of human meaning. Thus, as the layers of a neural network deepen, the AI system progressively develops increasingly refined and abstract synthetic analytical categories. This refinement is directed toward creating custom abstractions that are ever more relevant to the specific tasks for which the neural network was trained. Thank you for joining us on this exploration of categories of thought in artificial intelligence. You can find the article mentioned in the video, as well as all the work from Neocognition Lab on neocognition.org. See you soon for a new video.